Right now, I mean, literally right at this exact second, there is a multi-billion-dollar invisible war happening on your very own front porch.
Oh, yeah. Completely invisible. And it's huge.
Right. And it is entirely controlled by a piece of software that local florists, neighborhood pharmacies, and even the global shipping giants are all desperately fighting over.
It's actually wild to think about because, we have been completely conditioned to view delivery as, like, magic.
Yeah, absolute magic. You just tap a button and boom.
Exactly. You tap a glass screen, and 2 hours later, your groceries or a crucial prescription just appear. We really never stop to think about the massive humming digital architecture making it possible.
Which is exactly why today we're pulling back the curtain on that architecture. We're going on a deep dive into the hidden world of courier delivery app development. And just to be clear, the goal here isn't to teach you how to write code.
Right. No one wants to hear us read lines of code.
No, definitely not. It is to show you exactly how these platforms actually make money, the intense psychological and technological engineering required to run them without crashing, and what it actually costs to build one from scratch.
And we should probably establish right up front that this is not just an Amazon or Uber conversation.
Good point.
Yeah, if you look at the landscape today, the expectation of immediate trackable delivery has trickled all the way down.
Yeah.
Like, if you run any business moving physical items from point A to point B, you are suddenly expected to offer a digital experience that completely rivals the multi-billion-dollar corporations.
Okay, so let's unpack this because the stakes here are frankly staggering. According to Maximize Market Research, the global courier services market is projected to reach $712.07 billion by 2032.
Wow, over $700 billion.
That is billion with a B, yeah.
Yeah.
Growing at nearly a 6% annual rate. But to even compete for a tiny fraction of that pie, you have to realize that a delivery app isn't actually one app at all.
Exactly. It is an integrated ecosystem.
Yeah.
You are actually building 3 distinct, highly synchronized components at the exact same time.
Wait, 3 apps at once?
Yeah, basically. First, you have the customer app. This is what you, the user, open for booking and tracking. Then you have the driver app, which handles the incoming pickup requests, multi-stop routing, and proof of delivery.
So that's what the guy in the van is looking at.
Right. And finally, you have the admin dashboard. That's the overarching command center overseeing all the orders, the drivers on the ground, and the business analytics. Major players like DHL and UPS use this exact same 3-part ecosystem.
I always like to think of this system like a highly functioning restaurant.
Oh, that's a good way to look at it.
Yeah, so like the customer app is the dining room. It's beautifully lit. It has a great UI or user interface, meaning it's visually intuitive and it's where you sit comfortably to place your order. The driver app, on the other hand, is the kitchen.
Where it's absolute chaos.
Exactly. It's hot, it's loud, incredibly fast-paced, and all the actual heavy labor is being executed there. And the admin dashboard is the general manager sitting in the back office, monitoring the inventory and desperately trying to keep the dining room and the kitchen from just, collapsing.
What's fascinating here is that the analogy works perfectly, provided you include the most important part, the waiter.
Ah, okay. Where does the waiter fit into the software?
In software, that waiter is the API, the Application Programming Interface. It is the digital bridge that lets these 3 totally different environments talk to each other in milliseconds.
Because they're basically speaking different languages.
Yeah, or at least operating in completely different contexts. Without the API shuttling the order from the dining room to the kitchen, the whole restaurant falls apart.
But I have to ask on behalf of the small business owners listening, is it really necessary to build a complex 3-part software ecosystem just to deliver things?
I hear that a lot, yeah.
Because people have delivered packages for a century without an API. Couldn't a neighborhood pharmacy just use like a dedicated cell phone, some text messages, and a really well-organized Excel spreadsheet?
Well, the spreadsheet model actually breaks down much faster than you would think.
Yeah.
It's not about looking trendy. It's about basic operational survival.
Really? Just survival?
Yeah. The friction of growth kills manual systems. I mean, a spreadsheet is perfectly fine for 10 deliveries a day. You can coordinate that in your head. But at 50 deliveries, it becomes a nightmare. At 500 deliveries, it is physically impossible.
Because the human error compounds, like typos and stuff.
Precisely. Every time someone handwrites an address or mishears a zip code over the phone, or a driver takes a slightly inefficient route that costs time and money.
And it adds up fast.
It does. When you digitize the ecosystem, you eliminate the game of telephone. You integrate it with your CRM software. The data flows directly from the customer's phone into your business's central database without a human ever having to transcribe it. If you want to scale a business, you have to remove the bottleneck of manual coordination.
Which makes total sense. You cannot scale a delivery fleet if your head dispatcher is having a nervous breakdown every Friday afternoon trying to text 50 different drivers.
No, you definitely can't.
So we have this invisible three-headed monster of an ecosystem, and we understand why it's necessary for survival. But let's talk about the money. Building 3 interconnected applications cannot be cheap. How do businesses actually recoup this massive investment?
This is where the business strategy gets highly dynamic. You do not just charge a flat $5 delivery fee and call it a day.
Right, that wouldn't cover much.
Exactly.
Yeah.
A smart platform relies on a combination of different monetization models working in tandem.
Right, so the baseline is standard delivery fees. You pay a few bucks based on distance, the size of the package, or how urgently you need it.
Right.
But then you layer on merchant commissions. So if your app operates as a marketplace, say you are connecting local independent florists with buyers, you take a percentage cut of every successful transaction.
Which is a brilliant alignment of incentives. You only make money when the merchant makes money.
Then you have subscriptions. Customers pay a flat monthly or annual fee for unlimited deliveries or priority support, essentially the Amazon Prime model, right?
Exactly. Highly predictable revenue.
Then there are premium services charging extra for express speed, fragile handling, or white glove setup. You can even sell in-app advertising space to those local businesses so they show up first in the search results. But then there's surge pricing.
Ah, yes. The great controversial lever.
Let me push back hard on this one. Increasing delivery fees during peak hours or holidays is called surge pricing, and as a consumer, I completely despise it.
Most people do, yeah.
It always feels predatory. Let's say I'm a brand new startup trying to build a loyal customer base. Uber and Amazon already have my customers' loyalty. If a snowstorm hits and I suddenly triple my delivery fees, my customers are going to feel completely taken advantage of.
I get that totally.
They aren't just going to close the app, they're going to delete it. Why on earth would a startup risk that kind of permanent brand damage just for a short-term cash grab?
It is entirely understandable why customers hate it. But if we connect this to the bigger operational picture, surge pricing isn't actually a cash grab at all.
It's not.
No, it is an essential mechanism for survival during extreme bottlenecks.
How does charging me $20 for a $5 delivery help the business survive? That sounds like a cash grab.
Because it manipulates supply and demand in real time to prevent a total system failure. Take your snowstorm example. Or let's say it is the Friday before Mother's Day for a florist app.
Okay, high stress day.
Exactly. Suddenly, demand spikes exponentially. Thousands of people open the app to order at the exact same moment. But your supply of drivers has remained exactly the same. Or, in the case of a snowstorm, your driver supply might actually plummet because nobody wants to drive on ice.
Right, so the system is totally overwhelmed.
Exactly. If you keep the price at $5, every single one of those thousands of orders goes through. Your drivers physically cannot fulfill them. Delivery times stretch from 2 hours to 2 days.
Oh, and then the flowers die.
Right. Customers are furious, flowers arrive dead, and your brand reputation is destroyed anyway because you failed to deliver on your core promise.
So by raising the price to $20,
You immediately suppress the demand. A large chunk of people will look at that price, decide they don't need the delivery that badly, and close the app.
wow, okay.
And simultaneously, that $20 fee goes straight to the drivers, financially incentivizing more people to brave the snowstorm or log on during a holiday rush. You are artificially lowering demand while boosting supply until the system stabilizes.
That's wild. It is the only way to ensure that the people who absolutely must have their delivery can still get it.
Exactly.
Okay, that actually completely changes how I view it. It is a throttle. You are using price to manage the flow of traffic so the highway doesn't turn into a parking lot.
That's a perfect way to describe it.
And you can balance the frustration of surge pricing with the stability of the subscription model. Subscriptions give the startup predictable, recurring revenue to keep the lights on during quiet weeks, while the surge pricing ensures the servers don't melt down during a rush.
Precisely. And the way you generate revenue is heavily dictated by your operational model. Are you an on-demand service offering immediate fulfillment? Are you scheduled, running pre-planned daily routes?
Or corporate, doing bulk business-to-business stuff, or franchise.
Right. Or are you a crowdsourced model, relying purely on independent contractors logging in whenever they feel like it?
Which brings us to the actual blueprint. We have the business model locked in. Now, we face the massive wall of time and money to actually construct the software. The source outlines a 7-step development process, starting with market research and selecting a business model,
Which we just covered, yeah.
then deciding features, picking a tech stack, development, which includes UI, UX, front end and back end, then testing, and finally launch and marketing. But you don't try to build every feature at once.
No, never. You start with an MVP, a minimum viable product. You build the absolute core necessities first.
And deciding what makes the cut for the MVP is crucial. You need push notifications so users are alerted when a status changes.
Which drastically cuts down on expensive customer support calls, by the way.
Oh, I bet. And you need in-app chat, so a driver can ask a customer for an apartment gate code without having to leave the application. You need route optimization algorithms using mapping APIs to save on fuel. But the most critical MVP feature of all is real-time GPS tracking.
Yes, absolutely.
Here's where it gets really interesting, though. Real-time tracking is not just a logistical tool so you know where the driver is. It is entirely about hacking the user's psychology.
It is the single biggest driver of customer trust. Think about the profound anxiety of waiting for something important.
Like medicine or an expensive package.
Yeah. If you tell a customer their crucial prescription medication will arrive sometime before 8 p.m., they are tethered to their front window. The uncertainty breeds immense stress.
But if you show them a map with a tiny little car icon turning a corner on their street and a timer that says arriving in 4 minutes,
Their anxiety completely evaporates. They trust the system because they can physically see the system working. That little animated car is a digital pacifier. It gives the user a dopamine hit of control.
a digital pacifier. I love that.
Huh.
But creating that digital pacifier is incredibly complex behind the scenes. To make that little car glide smoothly on the map without glitching out, you have to choose the right tech stack.
Oh, this is the make or break technical decision.
Right, and this gets into the back end, the server-side brain of the operation. The source material highly recommends a back-end environment called Node.js.
Yeah, Node.js is famous for being extraordinarily efficient at handling real-time concurrent data streams.
Which is vital because I look at Node.js as an incredibly stressed out air traffic controller.
That's a good analogy.
Imagine you have 1,000 delivery drivers on the road. Every 3 seconds, each one of their phones sends a ping with their exact GPS coordinates to the main server. That is tens of thousands of data points hitting the system every single minute.
Yep, it's a massive load.
If your air traffic controller gets overwhelmed and drops those pings, the customer's app stutters. The little car icon suddenly jumps 3 blocks or looks like it's parked in the middle of a river. Node.js is the specialized technology that allows the system to juggle thousands of pings simultaneously without dropping a single one.
That analogy perfectly captures the chaos happening invisibly on the back end. But then we have the front end, the actual application installed on the user's phone. And for MVP, the prevailing wisdom for startups is to use cross-platform frameworks like React Native or Flutter.
Right, so instead of building the app natively, which means using the programming language Swift specifically for Apple iPhones, and a totally different language called Kotlin for Android phones, cross-platform lets you write the code once.
Exactly. The framework acts as a universal translator. If you build natively, you are literally building 2 completely separate applications from scratch.
Which sounds incredibly expensive.
Oh, it is. That means hiring an iOS developer team and an Android developer team. You are instantly doubling your development time and doubling your budget. React Native lets one single team write one set of code and deploy it to both Apple and Android app stores simultaneously.
But hold on, if it saves half the time and half the money, why doesn't literally every company in the world just use React Native? There has to be a catch.
There is, and it comes down to hardware integration. Cross-platform frameworks are amazing for standard features like GPS and push notifications, but they can struggle when they need to speak deeply to specialized hardware. Let's say your logistics company uses drivers who have to scan packages with highly specific, heavy-duty Bluetooth barcode scanners that pair with their phones.
Oh, like the ones in the massive warehouses.
Exactly. A universal translator like React Native might experience lag or fail to integrate smoothly with that specific external hardware.
Ah, so sometimes you need the native language to talk directly to the metal of the device.
Precisely. If your app requires heavy augmented reality, complex background processing, or niche hardware connections, you might be forced to spend the extra money on native development. But for like 95% of standard Courier MVPs, cross-platform is the undeniable strategic choice to get to market quickly.
So what does this all mean for the bottom line? We have our cross-platform code base, we have our Node.js air traffic controller perfectly routing our drivers, and we have an airtight business model. It sounds incredible on paper.
It does, doesn't it?
But let's face the harsh reality of actually funding this. What is the actual sticker shock here?
It is significant. A fully custom, enterprise-grade delivery ecosystem, meaning the customer app, driver app, and admin dashboard, typically runs between $50,000 and $150,000 to develop,
Wow. Up to $150,000?
and sometimes much more, depending on the complexity of the features. And that is strictly the initial build. Ongoing maintenance, server hosting, and bug fixes will run you between $1,000 and $5,000 every single month thereafter.
Given that massive $150,000 price tag, I have to imagine you aren't spinning this up in a weekend. Are we talking about a multi-year build process?
Not quite years, but it is a major time commitment. You're looking at 3 to 5 solid months just to get a basic MVP out the door.
Just for the basics.
Yep. If you want to add advanced custom-built route optimization algorithms or predictive analytics dashboards for the manager, that timeline easily stretches to 6 to 9 months of intense development.
Okay, I think we need to pause on that $150,000 figure, because if you look at the industry broadly, starting a basic analog courier business, just one person, a used van, some basic insurance, and a stack of flyers only costs a few $1,000s, right? Maybe $2,000 to $10,000?
Exactly. The barrier to entry is super low.
So the gap between a $3,000 analog startup and a $150,000 custom software bill is astronomical. If I am an entrepreneur, how do I justify taking out a second mortgage to build this?
This raises an incredibly important question about the fundamental difference between buying yourself a job and building a scalable asset.
Say more about that.
You can absolutely start delivering packages manually out of a van for $3,000. But you will hit a revenue ceiling by day 3. You can only drive so fast, you can only fit so many boxes in the back, you are trading your physical hours for dollars, and eventually you run out of hours.
So the software breaks the ceiling.
That $150,000 is not just buying code, it is buying profound operational leverage. When you invest in advanced route optimization, the algorithm calculates the absolutely perfect sequence of left turns to minimize time and traffic.
So you're saving on gas immediately.
Exactly. It instantly slashes your daily fuel costs and vehicle wear and tear across your entire fleet. When you automate dispatch and real-time tracking, you completely eliminate the need to hire a team of salaried customer service reps to answer the phone.
Because the software is doing the answering, the digital pacifier, like you said.
Exactly. As your business scales from 100 deliveries a day to 10,000 deliveries a day, the software handles the massive increase in complexity seamlessly. Over time, that initial $150,000 investment literally pays for itself entirely in the labor and fuel savings it generates.
But to make sure that $150,000 investment doesn't literally blow up in your face on launch day, you have to run it through an incredibly rigorous gauntlet of testing. You cannot just compile the code, upload it to the App Store, and cross your fingers.
Absolutely not. Testing is where the reality of the architecture is proven. You have to conduct exhaustive functional and usability testing, cross-platform testing, security checks. But the most critical hurdle is performance and load testing.
This is the ultimate stress test for our air traffic controller.
Yes. Imagine you skip load testing. It's Black Friday. Your marketing campaign worked perfectly, and suddenly 5,000 people open your app and place an order in the exact same minute.
Oh, that sounds like a nightmare.
It is. If the database isn't optimized to handle that massive influx of simultaneous read and write requests, the servers lock up entirely. The app crashes on the customer's phones. Worse, drivers out on the road suddenly can't mark their deliveries as complete or see their next stop.
Total blinding system failure.
Testing ensures the architecture bends without breaking under extreme pressure.
And it is worth noting that businesses rarely build this in-house. They partner with specialized US-based development agencies. The source mentions companies like Intellectsoft, which works with major enterprises, App Inventive, which has massive global scale, or Ninjascode, which specializes in translating business logic into these exact mobile ecosystems. You are paying for their battle-tested experience.
And before we summarize, it's vital to clarify one industry distinction that causes a lot of confusion. We have been discussing courier app development today. This is fundamentally different from logistics app development.
Right, let's clear that up. Courier apps are laser-focused on the last mile. Fast delivery of individual packages, hot food, or urgent documents directly to a consumer's front door.
Right. Logistics apps are massive macro systems managing the broader supply chain.
So warehousing inventory, managing fleets of 18-wheelers, and coordinating global freight across oceans. Logistics moves it across the world. The courier moves it from the local distribution center to your porch. Different scale, different software entirely.
Exactly. Just wanted to make sure we didn't conflate the two.
All right, let's recap this incredibly complex journey. We started by looking at a $712 billion market opportunity where digital transformation is no longer optional. We broke down the three-headed monster of the customer, driver, and admin applications and saw how APIs act as the essential waiters connecting the dining room to the kitchen.
Yep, the whole restaurant.
We explored the survival mechanics of surge pricing, not as a scam, but as a critical throttle to manage supply and demand bottlenecks. We looked at the blueprint hacking human anxiety with real-time tracking, using React Native to cut development costs in half, and relying on Node.js to manage the chaos of thousands of concurrent GPS pings. And finally, we faced the reality of a multi-month, potentially $150,000 development process that fundamentally pays for itself by buying massive operational leverage.
It is a monumental undertaking to build one of these platforms, but as we've seen, it is the absolute baseline required to operate a delivery business in the modern economy. The era of running a fleet off an Excel spreadsheet is completely over.
It really is. And I want to leave you with one final fascinating thought to mull over. We talked about crowdsourced delivery models where anyone can sign up to deliver. And we talked about advanced AI route optimization.
Right.
As these tech stacks get smarter and the AI calculating the absolute perfect multi-stop route gets faster, could we see a near future where everyday people automatically become ad hoc couriers?
Oh, that's an interesting thought.
Right. Imagine you are driving to the grocery store. An invisible algorithm calculates your exact route, realizes you are going to drive directly past a pharmacy, and pings your phone offering you $5 to grab a prescription and drop it off at your neighbor's house on your way back.
The line between a professional courier fleet and a neighbor simply running an errand could disappear entirely, all quietly guided by an algorithm calculating efficiencies we can't even see.
It's an incredible future to imagine. Thank you for joining us on this deep dive. The next time you tap that glass button on your phone and a package magically appears at your doorstep a few hours later, hopefully, you will look at that driver and the massive invisible digital engine humming behind them just a little bit differently.